G'day guys, question here on tangents and normals. I'm not sure what the exercise is, but let's just go anyway. C, find k if the tangent to y equals 2x cubed plus kx squared minus 3 at the point where x equals 2 has a gradient of 4. Let's start by attacking that one, shall we? So, the tangent to that particular function, well, the gradient of the tangent is just the gradient of the derivative. So let's find the derivative. dy dx is going to be 6x squared, 2 by k plus 2kx, and the derivative of 3 is 0, so that's okay. So there we go, 3 by 2 is 6, so it was 6x squared plus 2kx, and we know when x equals 2, the gradient equals 4. So we're going to let x equal 2, and dy dx equal 4. Now we just have to solve that. So away we go. 4 is going to equal 6 multiplied by 2 squared plus 2 by k by 2. 4 equals 6 fours are 24 plus 4k. You probably already figured it out. We'll subtract 24 from each side. I've got negative 20 equals 4k. Therefore, k equals negative 5. That's all you have to do for that one. Not so bad. Let's have a look at question 4, part A. The tangent to the curve y equals x squared plus ax plus b, where a and b are constants, is 2x plus y equals 6 at the point where x equals 1. Find the values of a and b. This one's just slightly nastier. First thing we know is at x equals 1, this is going to be true. And we know that this is the equation of the tangent. So tangent, I'm already thinking dy dx, aren't I? What's dy dx for this one? It's going to be 2x plus a. Now, this 2x plus y equals 6 is kind of annoying. Plus y equals 6, because we like to have it in our gradient intercept form, don't we? We have our linear equations in gradient intercept form, then we can tell what the gradient is. So if I just subtract 2x from each side, I've got y equals negative 2x plus 6. So I know that the gradient is equal to negative 2 when x equals 1. Oh, let's substitute that particular bit of information into this original one. So I'm going to let dy dx equal negative 2 and x equal 1. Therefore I've got negative 2 equals 2 times 1 plus a. I subtract 2 from each side. Negative 4 is equal to a. I'm on my way, but I haven't got this last little bit. At the point where x equals 1, this is the tangent. So that will tell me the y-coordinate where the tangent meets the curve, won't it? So we go ahead and find that out. So let x equal 1 in equation 2, and I'll go back and label them. This is my first equation, and this is my second equation. You could call it tangent equation or something else if you want. But that's fine. In equation 2, therefore I'm going to have 2 times 1 plus y equals 6, subtracting 2 from each side. I get the y value equals 4. So now I know the point of contact where the tangent touches the curve. It's at the point 1, 4. I can substitute that information into the original equation 1, and together with a equaling negative 4, solve for b. So equation 1 is going to become, what am I going to do? I'm going to let x equal 1, y equal 4, because I know that's the point of contact, and I've already figured out a is equal to negative 4. Going ahead and working this one out, I'm going to have 4 equals, well, x is 1, so this is just going to be 1 plus negative 4 times 1 is negative 4 plus b. Oh, that's going to give me -3, so I add 3 to each side, and I've got b equals 7. The question asks me to find the values of a and b. A equals -4, and b equals 7. Alright, pretty good. But we actually have one more question to go here, don't we? Whoa! How did I delete everything then? At least I got it back. See if I can get it to just snip out that part B. And then we'll scroll down and keep going with this last little bit. Alright, so I've got it in there. Now what we want to do is let's get over here and continue. Where's my pen gone? This is misbehaving. Alright, scroll up a bit, give us some room here. So the equation of the normal to a curve has this equation. So the equation of the normal, if I rearrange it, is going to be y equals -4x plus 22. That means the gradient of the normal equals -4. What does that tell us about the gradient of the tangent? It must be the negative reciprocal of the gradient of the normal. So that'll be -1 divided by -4, or just 1/4. So that's the first bit. The gradient of the tangent, when x equals 4, is 1/4. Okay, well, I better go ahead and find another way of expressing the gradient of the tangent, which is, of course, the derivative. So here, a root x, I'm going to rewrite as a x to the power of a half, plus b over root x is going to be plus b x to the -1/2. Remember to move something from the denominator up, take the negative of the power, or vice versa. All right, here we have our expression for y. So dy dx, do the derivative of this. What do we go? 1/2 times a, that's half of a. Subtract 1 from a half, and I've got x to the power of -1/2. Same procedure, -1/2 times b, negative b over 2, x to the power of, subtract 1 from -1/2, and I get -3 over 2. Now we've established that when x equals 4, the gradient of the tangent is 1/4, so I'm going to substitute in those values. Let x equal 4 and dy dx equal 1/4. What does that give me? I'm going to have 1/4 equals a divided by 2, 4 to the -1/2, minus b divided by 2, 4 to the power of -3 on 2. Alright, what's equivalent to that? Here I have 1/4. 4 to the power of -1/2, that's 1 over 4 to the half, which is 1 over 2. A over 2 times 1 over 2 is a divided by 4, minus 4 to the -3 on 2. Well, the negative is going to make it go to the denominator, so it's going to be 4 to the power of 3 on 2 in the denominator. Do this fractional part first. Square root of 4 is 2. 2 cubed is 8. Finally, 8 by 2 is 16. And so there I have the 16 there. That's pretty ugly at the moment. Let's just make it look a little bit nice. I'm going to multiply the whole lot by 16. So I'm going to get a nicer expression. 4 equals 4a minus b. Let's give that one a little asterisk in case I need to come back to it. We know we're going to, don't we? All right, I've got one equation in terms of a and b. I must be able to find another one. Well, I know when x equals 4, this equation is true. So let's go ahead and solve that one. Let x equal 4 in equation 2. And because I've gone to equation 2, remember, go back and just make it clear which equation you're working with. Therefore, 4 multiplied by 4 plus y equals 22. Subtracting 16, I'm going to get y equals 6. Therefore, the point of contact, or in this case, the point of intersection, where the normal intersects the curve, is at 4, 6. Well, that means if I substitute 4, 6 into the original equation, I will be able to get another equation in terms of a and b. Sub 4, 6 into equation 1. What does that give me? Oh, that gives me y equals 6 equals a times the square root of 4, which is just 2a. plus b divided by the square root of 4, which is b over 2. Let's multiply through by 2, just to get rid of that denominator. 12 equals 4a plus b. Let's give this one a star. So I've got a star and an asterisk equation there. Oh, the coefficients of a are the same, but even better, the coefficients of b, one's positive and one's negative. That is screaming out for a bit of elimination. Let's go. Asterisk plus the star equation. What do they give me? Well, I've got 4 plus 12 on the left-hand side, so that's just going to give me 16. 4a and 4a is 8a, and of course, negative b and b cancel each other out. Oh, dividing by 8, a is equal to 2. I'm going to substitute that into equation star. So a equals 2 into the star equation. 12 equals 4 multiplied by 2 plus b. That's 8. Subtract 8 from each side, and I have 4 equals b. So the numbers we're looking for are a equals 2 and b equals 4. There you go. I hope that helps. Keep up the good work. Keep the questions coming. Cheers.